So my name is Björn Skjolberg. I work as support engineer here at Know How, and this is the first out of two webinars about MDK ARM and how to get started. So we're recording this webinar, and if you have troubles hearing me, please write in the chat box because I have muted you all to reduce the background noise. So let's go. So I will show you today what you need to think of when you start your project with Keil MDK ARM. What you guys need to do for yourself and what has already been done by Keil, ARM, or your CPU vendor. Then I will show you a simple Blinky project, how you can get started, and a little bit of what you need to think of there. And then I will show you one of the news. Microvision has been implemented with a plugin for software versioning control system. So now I can communicate with my GitHub directly instead of going into some third-party GUI, which is quite nice, I think. But first, just a few words of know-how for those of you who don't know us. So we are distributors for solutions for embedded systems. We have 3 offices in Helsinki, Malmo, which is main office, and then Copenhagen. We deliver to Sweden, Finland, Denmark, and Norway. We are somewhat 18 employees, and we turn over about 5 million euros. So today I will talk to you about Keil and the Microvision and its development kit, which come from ARM. We also have debuggers, such as debuggers from Lauterbach, from Sega. We have static code analysis with Grammatech and PRQA. Unit testing from QA system called Cantata. And then Bluetooth analyzers from Frontline. And a little bit more as you can see here on this slide. So let's talk about MDK ARM. Well, there are 4 different flavors. We have the free version, which I'm using today. So everything I do, you can do as well for free. So the limitation of the free version is that you have a 32K maximum of code size. If you need more than 32K, then you should either go with the standard or with the Cortex-M. The difference between those two is that Cortex-M only supports the Cortex-M device, while the standard also do the secure cores and the legacy cores. And then for those of you who need a little bit more, we have the professional version. With the professional version, you also get the middleware packs. And this is for you who are looking for a TCP/IP stack, USB stack, and graphic library. So it's quite easy to get going with this middleware pack, and you will save a lot of weeks in development if you have these needs and be able to buy this pack. And then we have, for those of you who are looking to get certified, your project needs to get certified. So it's basically for the ARM compiler qualification kit. So it's for those of you who are looking at up to a SEAL 311 for IEC 61508 or a SEAL D in automotive in ISO 26262. So for those of you who are interested in this, we can have a talk about this afterwards. So let's go into the Keil MDK version 5. So what you have downloaded when you download this from the Keil webpage is the MDK core. So with the MDK core you have the IDE with the editor, you get the ARM C and C++ compiler, and you get the Microvision debugger with trace interface. And then you get the pack installer. The pack installer is just to make it more easy for you to to get your software in better organization, so to say. So you have the devices where you have the startup and such files. You have the SEMSys, which comes from ARM. And for those of you who have the professional, you have the USB, the TCP, and the graphical for this. So if you have any technical questions, please contact me, Björn Skånberg, for this, or if you have any sales question, please contact one of my co-workers in your respective country. So let's get into the technical part. So first of all, I want to show you my setup. So I use a Keil evaluation board with my U-Link Pro. And on this Keil evaluation board, there is a Cortex M4 from ST Microelectronics. So I have my Microvision open, and let's start by having a look in the pack installer. There we go. So for the pack installer, well, you can choose either. If I have an evaluation board, I can choose my evaluation board here, and then I get what packs I have available for this. Or I think in your case, it will probably, you don't have your project on evaluation board, you have it on somewhat customized hardware. So here you have to choose from the different vendors what CPU you are using. So for me, I'm using the Cortex M4. It's a 407 IG TX. So when I choose this, and you see since it's green here, I have it already downloaded. I get on the right what type of packs there is available for this CPU. So we have the device family pack, which is pre-made by ST, where you have the device support drivers and example. You have the SEMSys, which is the Cortex microcontroller software interface standard. This is more or less, if you have using RTOS and you want this to be SEMSys compliant, it's more or less an abstraction layer between the actual hardware and how the core should call the hardware. And then if you have the Pro version, you get the middleware, and then you have all of these others as well. So for each pack, there are different versions. So you can have a lot of different versions installed in your same environment. So right now I have 2.50 and 2.40 installed, but I can also install older. So this is good for if you're having one project which you do maintenance on, and you will like to then you must have the same packs that project was built on. But then you also do some development on a new project. Then you will probably like to use the newest ones. You can switch quite easily between this. Okay, so we'll go into Microvision. So let's start a new project. So we'll start it here. We can call it Web Blinky, and then we just call it Blinky. Save. So now I have to choose the CPU I'm using on. So I'm using the F4, F07, F07 IG, and then TX. I click OK, and now the runtime environment will appear for me. Because I have an evaluation board, there has been a board support package made for me. So it basically contains functions on how to turn the LED on and off, and what peripherals I need to use for this, and drivers for this peripherals. But since you guys probably don't use an eval board, I will show you how you would do if you didn't have this board support package, if you will do it from scratch. So we're doing a Blinky, and a Blinky probably needs a GPIO. So you go into device, you go into the hardware abstraction layer, you choose the GPIO. Okay, to be able to use the GPIO, Keil is telling me that you have to have the common file. So I will click it. And then to have the common file, you need to choose what framework. So I will click that. And you see there are a lot of dependencies that comes. So you can either click them one by one to select them, or you can just click resolve and Keil will do this for you like this. So this is not something that I have done. This comes from the device family pack from the ST microelectronics. So from your MCU vendor, you will have the same mechanism when you're supposed to use the GPIO. So I would like to have an RTOS as well, because I like to work with an RTOS. So I will choose the Keil RTX. And for this, I need the device startup. And so this is how you would do if you don't have an eval board. But since I have an eval board, I would like to use the functions that are available for it as well. So I will do that. So I will click the LED. Now you will see the project will appear on the left side. So I told you before that you can have a lot of package installed in your environment, so you can switch between developing new projects and doing maintenance on old projects. And this is done by using the select software pack. So you can either have it set to use latest version of all installed software packs, or you can deselect this and you can go into device family pack and to tick the box of what pack you would like to use. So it's quite handy to just switch between projects. Okay, so now I need a main file. So I'll right click. If you don't have it written before, you had to do add new item to group. So here you have two options. You can either go choose a C file and then do main.c and click add, or you can use the user code templates, because when we chose the peripherals and so on in the runtime environment up here, you see that the device and the SEMSYS has been selected. So with this, ST Microelectronics has done a few example codes which you can use in your development, so you don't have to write it from scratch. So I would like to have a main function. So I'll click add, and the main function will appear. So it's quite nice and easy. With this, I would like to have a thread that's doing the actual blinking. So I will add one more item. I can choose C file or user code templates. So here you see that there are quite a few functions available for the Keil RTX. So I want to use thread, and I will call it LED thread. I will click add. So now you see a kind of a shell has been added for my thread, and I just need to fill in the little stuff, so to say. So I use the functions I got with my eval board. I will initialize the LED, and then I will just do LED on with auto completion. So if you have something you know almost what it is, you can always click Control Space. Sorry, you have to have the semicolon. So you can click Control Space and Keil will show you, okay, this is what you have available. I would like it to rest for 250 milliseconds. I will go LED off, and I will then delay it for another 250 milliseconds. Or 250 milliseconds. And then I need, in my main function, I need to call the init. So I need to put extern, and now auto completion init thread. Okay. So then I would like to compile F7. Usually takes a few seconds because it's the first time we compile. Here we go. And now I need to choose how to flash it to my target. So I go options for target, this one here. I go debug, and then I choose the debugger I'm using. So as you can see, there are quite a few available for in the MicroVision. So I use the Ulink Pro Cortex debugger. I click settings. So now in settings, first I need to look for it's okay, I get the ID code of the CPU, which means that the debugger can sense the CPU and that I have connection. And I also need to make sure that there is some kind of flash declared and how I should flash. So this was already here because in the beginning I chose the CPU STM32F407 IGTX, and in that description of that CPU it's known that there's on-chip flash at this address range. But however, if this should be wrong, then you can always add it by yourself by clicking add, and then you get what algorithms you have available. So I can click add, and then just now I have two, but really I don't, so I will remove it. We click OK, we click OK. So it has been loaded, and if I reset my board, you see that the flash is blinking. So quite nice and easy. So just to recap what I just said is to, when you start your project, use the pack installer and make sure you have installed all the packs. And also have a look at the examples to see what you have available and what you can start from. And then you had the select software packs, which is basically if you're working on a new project, you will have used the latest version, or if you're working on some maintenance project, you will probably have to use the older one that software was built with. And then we have the runtime environment with this. So where you choose the different components and such things. But let me show you how the integration is working with the Git. So Keil has now, they have a software control versioning system, so you can communicate with your GitHub directly instead of going to some third-party GUI. So let me show you how this is working. What do we have? So we do webinar 2, and we do a folder called webinar 2 coworker. I will show you later why I do the coworker. So if we go to webinar 2, I will do a git clone, and I will put it from here. So now it will just give me the username, password, and it will copy it for me. And then we just move one step backward. Webinar 2 coworker, and we do the same username. There we go. So let's open the project which we just copied from Git. So it's called Web2 FPU project. So here we go. So here we have functions. We have a code. You're working on your code, and let's say you do a new function. We can call it mult for multiply. We give it to integers. We would like to return the result. And we just say comment mult functions, and we can give it today's date. So now I would like to upload this to my GitHub because I cloned it from Git. I have the git init file already in my project folder. So I'm now working on my local copy, so to say. So to configure this, you need to go to SVCS, configure software versioning control. Click here, and then you must choose the template file. The template file you will find in the installation directory of Keil, and then UV4. So as you can see, there are a few available. So it's depending on what type of versioning system you use. I use Git, so I will choose Git. With this, I will get a little menu that will help me, so I don't really need to do too much typing. So I click OK, and if we click again now, you will see that the menu has been added. So to upload this function that I just made, I will stage thread C, we'll do a git add. I will commit stage changes, so added function mult. I will click OK. So now you will see that one file change, 6 iterations, and then I just push commits to server. So here I have to give my username again. However, this can be configured away. It's just because I want to show you the whole process. And then my password. So there we go. Now you see that the Git has been pushed to this Bitbucket address. So now I should open my coworkers project. So if we open this, so now he's working on his local copy, so to say. And he will not have the multiplication function, which I just did. So for him, it's just go into the menu and then pull latest version from server. Just give the username, give the password, and this will be pulled. So you will see thread C, there are 6 changes, and the multiplication function has been added. So this was it for today. I hope you enjoyed it. I will unmute you all. There we go. So if you have any questions, speak up and ask me. I will just talk